In this video, we will do examples 8.5 to 8.10 from the 11th Maths from chapter 8.7. Example 8.5. Find the direction ratio and direction cosines of the following vectors. So let's do the first one. So the first one, let's assume our vector r is equal to 3i cap plus 4j cap minus 6k cap. Now if vector r is in the form xi cap plus yj cap plus zk cap, and so we can define r as equal to, which is the magnitude of r vector, square root of x squared plus y squared plus z squared, and x by r, y by r, z by r will be the direction cosines, and x, y, z will be direction ratio. So here, substituting the values of x, y and z, we can say that 3, 4 minus 6 is the direction ratio of 3i cap plus 4j cap minus 6k cap. Similarly, we can say 3 by, let's quickly calculate our r. R will be equal to square root of 3 squared plus 4 squared plus minus 6 squared. That's equal to square root of 9 plus 16 plus 36, which is equal to square root of 61. So x by root 61 comma 4 by root 61 minus 6 by square root of 61 will be the direction cosines of the vector 3i cap plus 4j cap minus 6k cap. It's very simple. You take the coefficients of I cap, j cap and k cap. They become the direction ratio. Then you find the length of the vector, which is r is equal to square root of x squared plus y squared plus z squared, and then take the coefficient of I cap divided by the total length of the vector r, that with similarly y divided by the length r and z divided by length r will be the set, which will be your direction cosine. So the second part of the question is 3i cap minus 4k cap, and we need to repeat the same thing. So here the coefficients of I cap, j cap and k cap will be 3, 0, the coefficient of j cap is 0, minus 4 is our direction ratios for the vector 3i cap minus 4k cap, and 3 by, we need to find our r. R will be equal to square root of 3 squared plus minus 4 squared, which is equal to root of 9 plus 16, which is equal to root of 25. That's 5. So 3 by 5, 0, minus 4 by 5, or the direction, we call this r, cosines for the vector 3i cap minus 4k cap. In example 8.6, question number 1 says, find the direction cosines of a vector whose direction ratio is 2, 3 and minus 6. So we know if x, y, z are the direction ratios of a given vector, then our direction cosines will be x by square root of x squared plus y squared plus z squared, y by square root of x squared plus y squared plus z squared, z by square root of x squared plus y squared plus z squared. So here, replacing, we can say that our direction cosines will be 2 by square root of 2 squared plus 3 squared plus minus 6 squared, comma 3 by square root of 2 squared plus 3 squared plus minus 6 squared, minus 6 by square root of 2 squared plus 3 squared plus minus 6 squared, or our direction cosines. Further simplifying this, we can say 2 over 7, 3 over 7 minus 6 over 7 or the direction cosines. The second part of the question is, can a vector have direction angles as 30 degrees, 45 degrees and 60 degrees? We know that for direction cosines, you need cos squared alpha plus cos squared beta plus cos squared gamma to be equal to 1. And here, for alpha is equal to 30 degrees, beta is equal to 45 degrees, and gamma is equal to 60 degrees. So if we take the left hand side and say cos squared of 30 degrees plus cos squared of 45 degrees plus cos squared of 60 degrees, that would be equal to square of root 3 by 2 plus 1 by root 2 squared plus 1 by 2 squared, and that's equal to 3 by 4 plus 1 by 2 plus 1 by 4. If you simplify this, you will get 4 over 3 plus 2 plus 1, which is equal to 6 by 4, and this is not equal to 1. Therefore, LHS is not equal to RHS in 1. Therefore, they are not direction angles of any vector. The third part of the question is, find the direction cosines of the vector AB, where A is 2, 3, 1 and B is 3, minus 1 and 2. So AB vector will be defined as vector OB minus vector OA. So that would be, what is our OB vector? OB vector is 3i cap minus j cap plus 2k cap minus our OA vector will be 2i cap minus 3j cap minus k cap, and that's equal to I cap minus 4j cap plus k cap. Now our direction cosines are, let's find the magnitude of AB. That would be equal to 1 squared plus minus 4 squared plus 1 squared, which is equal to square root of 18. So our direction cosines are 3 over root of 18 minus 4 over square root of 18, 1 over square root of 18. The fourth part of the question is, find the direction cosines of the line joining 2, 3, 1 and 3, minus 1 and 2. This is similar to the previous problem. So you have point A as 2, 3, 1 and point B as 3, minus 1 and 2. So this is the line AB. So we need to find the direction cosine of this line. So first let's consider the vector from A to B. So what would be our direction cosine of AB? If A is 2, 3, 1 and the point B is 3, minus 1 and 2, then the direction cosines of vector AB are 1 by square root of 18 minus 4 by square root of 18 and 1 by square root of 18. This we already found in part 3 of the problem. Now, but any point can be taken as first point, which means you can take B also as the first point. Hence, we have another set of direction cosines with opposite direction. So, the other of cosines are minus 1 by square root of 18, 4 by square root of 18 and minus 1 by square root of 18. The last part of the question is, the direction ratios of a vector are 2, 3 and 6 and the magnitude of the vector is 5. Then find the vector. So we are given the direction ratios, or rather a set of direction ratio. So direction ratio is given as 2, 3 and 6. Now we can find the direction cosine using this. So a direction cosine will be, what will be the square root of 2 squared plus 3 squared plus 6 squared will be equal to 4 plus 9 plus 36, which is equal to 7. So our direction cosines will be 2 by 7, 3 by 7, 6 by 7. We know that if this is our x, y and z in a vector, then this is a unit vector. So the unit vector can be written as two by 7 I cap plus 3 by 7 j cap plus 6 by 7 k cap. This would be a unit vector with the same direction angles of the required vector here. Now we know the magnitude is 5. So this unit vector magnitude is 1. So multiplying them with 5, the required vector is 5. You can bring the 7 out as common and we can write it as 2i cap plus 3j cap plus 6k cap. So I have just multiplied them all with 5. In example 8.7, show that the points whose position vectors are 2i cap plus 3j cap minus 5k cap, 3i cap plus j cap minus 2k cap, and 6i cap minus 5j cap plus 7k cap are collinear. So let O be the origin. And then we can define our vector OA as 2i cap plus 3j cap minus 5k cap, and vector OB as 3i cap plus j cap minus 2k cap, and vector OC as 6i cap minus 5j cap plus 7k cap. Our vector AB is equal to OB vector minus OA vector. So subtracting OB from OA, you get 3 minus 2 is 1. So I cap 1 minus 3 will be minus 2j cap, and minus 2 plus 5 will be plus 3k cap. Similarly, our vector AC can be written as 6 minus 2 will be 4i cap minus 8j cap and plus 12k cap. You can clearly see that our vector AC is multiplied 4 times by vector AB. So 4 times of I cap will be 4i cap, minus 2 times of 4 will be minus 8j cap, 3 times of 4 will be 12i cap. So we can say that vector AC is equal to 4 times of vector AB. Therefore, AB vector and AC vector are parallel and they have the same common point A. Therefore, the 3 points are collinear. Example 8.8. Find a point whose position vector has magnitude 5 and parallel to the vector 4i cap minus 3j cap plus 10k cap. So in such a problem, you need to first find the unit vector of the required vector, and then you can multiply it with 5 or the required magnitude. So since our required vector is parallel to this vector, the direction cosines should be the same. Therefore, we can say let vector A be defined as 4 I cap minus 3 j cap plus 10 k cap. Then the unit vector A cap along the direction of vector A is vector A divided by the magnitude of vector A, and this will be equal to vector A by magnitude of A. So let's just try and quickly work out our magnitude of A here. That would be equal to square root of 4 squared plus minus 3 squared plus 10 squared, and that should be equal to square root of 16 plus 9 plus 100, which is equal to square root of 125, which is equal to 5 times root of 5. Okay, so this will be equal to now 4 I cap minus 3 j cap plus 10 k cap divided by 5 root 5. Therefore, the vector whose magnitude is 5 and parallel to 4 I cap minus 3 j cap plus 10 k cap is 5 into 4 I cap minus 3 j cap plus 10 k cap divided by 5 root 5. That would be equal to 4 I cap divided by root 5 minus 3 by root 5 j cap plus 2 root 5 k cap. So a required point is 4 by root 5 minus 3 by root 5 2 root 5. Example 8.9. Prove that the points whose position vectors 2 I cap plus 4 j cap plus 3 k cap, 4 I cap plus j cap plus 9 k cap and 10 I cap minus j cap plus 6 k cap form a right angle triangle. So for this, we need to see whether these points make a right angle triangle. So let's define, let O be the point of origin and A, B and C be the given points. So let's define our OA vector as 2 I cap plus 4 j cap plus 3 k cap, which is our first vector here. Then let's define our OB vector as the second one, which is 4 I cap plus j cap plus 9 k cap, and our OC vector as 10 I cap minus j cap plus 6 k cap. Now our vector AB can be written as vector OB minus OA, and that would be equal to OB minus OA. By subtracting 4 minus 2, you get 2 I cap, 1 minus 4 minus 3 j cap, 9 minus 3 will be plus 6 k cap. Similarly, we can also find BC vector, and that would be equal to OC vector minus OB vector, and that would be OC minus OB would be 10 minus 4, which is 6 I cap, minus 2 j cap, minus 3 k cap. Similarly, our CA vector will be OA vector minus OC vector, and that is equal to minus 8 I cap plus 5 j cap minus 3 k cap. Now we can find the magnitude of AB vector as square root of 2 squared plus minus 3 squared plus 6 squared, which is equal to square root of 2 plus 9 plus 36, which is equal to root of 49, which is 7. Similarly, the magnitude of BC vector is equal to square root of 6 squared plus minus 2 squared plus minus 3 squared, which is equal to square root of 36 plus 4 plus 9. This is 4 here, sorry. So it's square root of 49, which is equal to 7. Similarly, the magnitude of CA is equal to square root of minus 8 squared plus 5 squared plus minus 3 squared, which is equal to square root of 64 plus 25 plus 9, which is equal to square root of 98. So if we take our AB squared, which will be the magnitude of AB, the squared, which is 7 squared, that will be 49, and our BC squared will be equal to magnitude of BC, the squared, will be 7 squared, which is also 49, and our CA squared will be equal to magnitude of CA, the squared, which is root of 98 squared, will be 98. Now you can clearly see our CA squared, this value is equal to the sum of these two values. CA squared is equal to AB squared plus BC squared. Therefore, the given points form a right angled triangle. Example 8.10. Show that the vectors 5i cap plus 6j cap plus 7k cap, 7i cap minus 8j cap plus 9k cap, 3i cap plus 20j cap plus 5k cap are coplanar. To prove this, we have to show one vector as a linear combination of the other two vectors. So to start with, let's define, or let's say 5i cap plus 6j cap plus 7k cap be equal to, let's use a scalar s and multiply with the second vector 7i cap minus 8j cap plus 9k cap. And let's multiply the third vector with the scalar t. T times of 3i cap plus 20j cap plus 5k cap. Now equating the coefficients of I cap, this is 5 here, and here it will be 7s plus 3t. So you get 7s plus 3t is equal to 5. Similarly, for j cap, we can say that minus 8s plus 20t is equal to 6, and 9s plus 5t is equal to 7. So if we solve these three equations, we can find, solving the first two equations, we get our s is equal to t is equal to 1 by 2, which satisfies the third equation. So if you solve the first two equations and then put the half which we get for s and t, the third equation, it will be 9 by 2 plus 5 by 2. That will be 9 plus 5 is 14. 14 by 2 will be equal to 7. So it satisfies the third equation also. Therefore, we can say, thus, one vector is a linear combination of other two vectors. Hence, the given vectors are coplanar.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.